Whenever we measure any physical quantity, length, distance, time, we should describe it with a proper SI unit. Quantities which are derived from these 7 base quantities or fundamental quantities is called as derived quantities. In case of radian, we use theta. In case of solid angle, for 3D sphere, we are using omega. Once you get to know what is d, you can calculate what is the diameter or angular size of that planet. Hello everyone, hope you all are doing good. I am Nishpananjama, Faculty of Physics in Vidyashram Pre-University College, the Temple of Excellence, Mysuru. Dear student, welcome back to session 1 on chapter 1, that is units and measurement. So in this units and measurement, we observe many phenomena surrounding us, which may be man-made or which may be natural. So in order to describe any phenomena, we need to measure the different physical quantities that it is associated with it. It is essential. So in order to understand this phenomenon, let us take an example of fruit falling from a tree. It is a natural phenomena. To understand this phenomena, we need to know which height does the fruit fall from, how much time does it take to reach the ground, what speed does the fruit fall, all these physical quantities associated with this. To answer these questions, we need to measure these different physical quantities, that is the height, distance, time, etc. So, if you can understand all these physical quantities, you can understand this natural phenomena. So, a measurement of physical quantity, we require to describe it with a proper unit. So, whenever we measure any physical quantity, length, distance, time, we should describe it with a proper SI unit. It is important. So, in this chapter, students, let us try to understand what are that units, measurement, and what are all the different physical quantities that you measure, how you assign units. So, that will come across in this session. And also, we'll measure length, masses for different particles or object of different ranges. What are all the instruments, apparatus used in order to measure the length of the particle or mass of the particle and measurement of time. All these topics will be covering in this session 1 of chapter 2, that is units and measurement. So let's start. What do you mean by unit, or what do you mean by physical quantity? How do you measure? Let us take an example. You'll measure a length of the stick or length of the rod, or you'll measure your height, weight. How will you measure these quantities? For example, let us consider this pen. Suppose the length of this pen is 10 centimeter. I'll write the length of this pen is 10. 10 what? 10 kg? 10 second? 10 Kelvin? What? 10 what? The length of this pen is 10 centimeter. So this centimeter gives you the unit of length. Length is described by 10 centimeter or 10 meter. This is the length. Length measurement is taken in meter. For example, consider, I'll measure the weight. You can see here in this image. I'll measure my weight. My weight is supposed to be 55.4. I'll ask you, what is your weight? You'll tell 55.4. 55.4 what? 55.4 meter, 55.4 Kelvin, or second what? 55.4 kg. If you tell your weight is 55.4 kg, that will help me to understand what is your weight. So, weight that describes the mass, 55.4 kg. This is your weight. For example, your mom will ask you to get a 5 kg of rice. You'll go to a grocery store. You'll ask the shopkeeper 5. He'll be in a dilemma. He'll be in a confusion. 5 what? What are you asking for? Either he will give you 5 grains or 5 bag of rice. What it exactly is? What are you asking for? You should be clear. It is 5 kg of rice. So that describes how quantity of rice you need. So mass is measured in terms of kg. You want 55 kg of rice or 5 kg of rice. The shopkeeper will give you 5 kg of rice. So, always it is important that you describe that particular physical quantity with the help of the unit. So, it will be helpful for us to understand what are you exactly asking for, what measurement it is, what kind of measurement it is. For example, you have asked for 5 kg of rice. Look at this, 5 kg of rice. 5 is what? It's a numerical value, the measurement of rice, that is 5. Kg is what? Unit of mass. 5 kg of rice. So, a physical quantity, what are you measuring here? Rice. So, you are measuring a physical quantity, and this physical quantity is given with a unit, that is kg. So, 5 kg is the measurement of rice. That much rice you require. Or you consider the 10 centimeter. The length of the pen is 10 centimeter. 10 is what? 10 is the length of your pen. 10 is the physical quantity that you are measuring, that gives the length of your pen. So, this is your physical quantity. What is centimeter? That is the unit that is describing this particular physical quantity. Similarly, 5 kg. 5 is what? 5 is the quantity of rice you require. You are making a measurement. 5 is a numerical value. So, kg is what? It is describing that particular physical quantity. So, a numerical value is described with respect to a unit. So, this is what we call it as unit. This is what we call a physical quantity is given with respect to unit. This is how we do measurement. So, here you can read, students. What is unit? The chapter deals with unit and measurement. You got to know how you do measurement. You measure the pen. It is 10 centimeter. 10 is what? It is the length of the pen. The numerical value describes the physical quantity. The physical quantity is given with a unit. That is, pen is measured in terms of centimeter. So, it will help me to understand it is 10 centimeter. What are you exactly measuring? So, unit. Internationally accepted reference standard used to measure any physical quantity is called unit. So, internationally accepted reference standard used to measure any physical quantity is called unit. So, this is your unit, and 5 kg of rice. You are measuring 5 kg of rice. 5 is that is the physical quantity. Amount of rice you are measuring is the physical quantity. Length of the pen, that is the measurement made. So, length of the pen is a physical quantity. Distance, time, all these are some of the physical quantities. So, the unit used to describe those physical quantities are called units. It is internationally accepted reference standard to describe that particular physical quantity. So, what do you mean by physical quantity here? Physical quantity is any quantity which can be measured and given in terms of numerical value is a physical quantity. Any quantity that can be measured. I can measure the length of the pen, so it's a physical quantity. I can measure the how many amount of rice you require, so it is again a physical quantity. I'll measure what is my weight, what is the length of the rod. All these are physical quantity. So, this physical quantity is measured in terms of numerical value. So, length of the pen, it is 10. It's a numerical value. Mass of rice, it is 5. My weight, it is 55.4. 55. All these are numerical value. And in terms of numerical value, that is physical quantity. And this numerical value, that's the physical quantity, is described with the help of unit, that is 5 kg or 10 centimeter. So, this is the unit and physical quantity. How we measure things, and that numerical value is given with respect to unit. So, that will help you to understand how you measure and assign units to that particular measurement. So, some examples for physical quantity are length, mass, area, volume, etc. So, here you can see how you measure your weight, length, volume. So, all these are physical quantity. Whenever this physical quantity are measured, they are given in terms of a numerical value. 55.4 is my weight, 10 is the length of the pen, or 5 kg of rice. All these are given in a numerical value. These are the physical quantities that I have measured, and these physical quantities is assigned with a particular unit, that is the standard unit used to describe a physical quantities. So, next is international system of units. So, what do you study in this international system of units? You can see a tabular column here. So, different part of the world is to use different SI systems, that is different system of units, that is MKS, CGS and FPS. So, different part of the world, different countries used to use different system of units. You can see MKS, CGS, FPS. So, what is MKS? Meter, kilogram, second. What is CGS? Centimeter, gram, second. So, what is FPS? Foot, pound, second. So, these were the system of units that was used earlier, but due to inconvenience in the measurement, it was seen that there was inconvenience of measurement, that if you measure the mass in kg here, maybe when you go to some other part of the country or some other place, they used to not use the similar thing. So there was inconvenience in the system of units that you use for measurement. So what did they do is, in 1971, they came up with SI unit, which is standard for all the places, that is, you use System International of Unit, SI unit, for all the measurement, which was followed everywhere. That came up in 1971. System of unit which is internationally accepted at present for the measurement is International System of Unit, abbreviated as SI unit. So SI unit is currently accepted as system of units for measurement everywhere since from 1971. Earlier it was not the case. Earlier you had different system of measurement in different parts of the world. So next you have physical quantities. I have already explained you what are the physical quantities. Some of the physical quantities are length, mass, time, temperature, luminous intensity, many. There are large number of physical quantity. There are large number of physical quantity, say from length, area, volume, density. There are so many. So I need only minimum limited number of physical quantity for which unit has to be described. Which are those minimum physical quantities that I require? Those minimum physical quantities, we call it as fundamental quantities or base quantity, fundamental quantity or base quantity. It has 7 base units, which is minimum limited number of physical quantities. Those 7 base units we call it as fundamental quantities or base quantity. Example, mass, length, temperature, all these, etc. So the unit that describe the fundamental quantity is called fundamental unit. The unit which describes the fundamental quantity is called fundamental units. So there are 7 base units. We'll look at what are the 7 base units in our next slide in this session. So then what is the derived quantities? What do you mean by derived quantities? The word itself says it's derived. So these derived quantities are derived from these fundamental quantities. The quantities which are derived from these 7 base quantities or fundamental quantities is called as derived quantities. For example, say that you have 2 paints with you, say red and white, but you don't have pink color paint in your box. So what you want to do? You need to paint pink color. So what you'll do? You'll mix red and white. So red and white mixing up of these two will give you pink color. So from the fundamental quantities, you are deriving a derived quantities, that is the pink color. So similarly, area, velocity, volume are the derived quantities which can be derived with the help of this fundamental quantities. So unit that describes the So the unit that describes this derived quantities is called derived unit. So few examples for derived quantities are area, velocity, volume, etc. So physical quantities, there are large number of physical quantities. So we need minimum limited number of physical quantity for which the unit has to be described. So physical quantities is classified into fundamental units and derived units. Fundamental units are minimum limited number of physical quantities. That is nothing but the base quantities. You can call it as base quantities as well. So there are 7 base quantities or fundamental quantities that we'll see in our next slide. Few examples are mass, length, temperature, etc. So derived quantities, we derive those quantities from these fundamental quantities and they are called as derived quantities. For example, area, velocity, volume, etc. We derive those from this fundamental or the base quantities. Which are those derived quantities? Even that will come up in our next slide. So next you have fundamental quantities and units. As I mentioned, there are 7 fundamental quantities. You can see here. There are 7 fundamental quantities or base quantities. Which are those? Length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. These are the 7 base units, students. So from these 7 base quantities, we are deriving the derived quantities. We'll come to that. So first is the fundamental quantity, that is length. What is length? You measure the length of the pen, you measure the length of the shirt. All these are the measurement that gives the length. So length is the fundamental quantity, unit is meter and symbol is m, small m. So next, mass. Mass is the second fundamental quantity and unit is kilogram, symbol is kg. And third is time, unit is second and symbol is s. Next, you measure electric current, the unit is ampere and symbol is A. Next is thermodynamic temperature, unit is Kelvin, symbol is K. Next you have amount of substance, how much substance. So unit is mole and symbol is MOL. Next, last is luminous intensity, the system of unit, it is candela and symbol is small CD. So these are the 7 fundamental quantities. You can remember what are the units that you measure them with and these are the symbols that you use to represent them. So these are the 7 base unit, minimum limited of physical quantities. From these we will derive the derived quantities. How we'll derive? You should remember the 7 base quantities along with their units and what are the symbols we use. So next, along with the fundamental units, students, before we go to the derived units, along with the fundamental quantities, fundamental units, you have something called as supplementary units, supplementary quantities. Supplementary units, there are 2 supplementary units. One is radian and second one is steradian. With these two, first let us try to understand what is radian. What do you mean by radian? So these are the 2 supplementary units along with the fundamental quantities. So radian, how will you measure? You can see this diagram. Consider this diagram to explain radian. Radian is the angle made at the center of the circle, by an arc whose length is equal to radius of the circle, d theta is equal to ds by r. So why we use radian is, we use to measure a plane angle. To measure a plane angle, that we use theta here. To measure a plane angle theta, we use radian and radian is represented as RAD. This is the symbol that we represent the unit, SI unit, radian. Radian is used to measure a plane angle. Suppose in radian we will consider a 2D circle. To define radian, we will consider a 2D circle. Consider this is a 2D circle, this is a center point. From center, you will draw a line. Similarly, this is the center point O. This is the radius of the circle. Similarly, you will cut one more line that joins the circumference of circle. You will take it as R. You will cut one more line. You will join this line to the circumference of circle. Circumference of circle, you know, it's 2 pi R. If I draw it separately, it will look like this. This is the center O. This is the R radius that cuts the circle. Similarly, I will join one more line which cuts the circle and I will join one more R. So, I will join in the form of circumference of circle. So, this is length of arc. This is length of arc, that is nothing but ds. This is the length of in circle. We will consider it as length of arc, which is ds, and this angle is theta. It is 1 radian. So, how will you define radian? It is the angle that is in circle, we'll take it as theta. To measure radian, we'll consider theta. So, change in theta, that is d theta is equal to ratio of length of arc, that is length of arc divided by radius. Change in angle is equal to ratio of length of arc to the radius, that is nothing but ds by r. D theta is equal to ds by r. And change in angle is equal to ratio of length of arc to the radius r. So, what we studied here, radian is the unit that describes the plane angle, which is represented as RAD, and to describe radian we will consider a 2D circle. In 2D circle we will consider a center point, you will cut a line to the outer surface of the circle, which is taken as radius r. Similarly, you will cut one more line to the circumference of circle, that is r. Similarly, you will join one more r in the circumference of circle. It will look like this. You can see it look like this. So, this is the, we consider it as length of arc in circle. So, d theta is equal to length of arc by radius. So, length of arc is nothing but ds and r is the radius. So, d theta is equal to ds by r. So, radian is the angle made at the center of the circle by an arc whose length is equal to the radius of circle. So, this is about the radian. Next, you have steradian. Steradian is used to measure a solid angle. To measure a solid angle, we consider steradian, which is given by symbol small s and r. To measure solid angle, we consider steradian. To explain steradian, see, I have put a simple and fascinating image that you can understand this concept easily. So, to explain steradian solid angle, what I will take? I should take a 3D picture. So, you should imagine yourself the 3D image of sphere. So, to explain a solid angle, that steradian is used to measure a solid angle. To measure a solid angle, I will consider a sphere. Here I have considered a watermelon. Imagine a 3D image. So, you can see a cone here. You can see a cone here. What will happen is, this is your surface. The surface is nothing but dA. The surface is nothing but dA, and this, when all the lines from the surface is joined to center point O. When all the lines from the surface is joined to center point O, this O will form an angle. This O will form a solid angle in the cone. That solid angle is represented by d omega. So, this is the surface of the cone in the 3D image. So, when you join all the surface, that is all the dA lines to the center apex O, this apex O will form an angle, that is solid angle with respect to the surface dA, that is nothing but d omega. So, d omega is given by dA by r square. dA by r square. So, how will you define steradian now? Steradian, it is a solid angle. It is a solid angle, that is this one. It is a solid angle subtended at the center of the circle by a surface of the sphere whose area is equal to, area is equal to radius of the sphere, square of radius of a sphere. D omega is equal to dA by r square. So, this is about steradian and radian. So, in this slide we learnt about the supplementary units, that is radian and steradian. Radian, the unit is RAD, and for steradian the unit is small sr. So, steradian is used to measure the solid angle. Here we will consider the 3D sphere. All that is, you have to imagine. This is my imagination. In 3D, we are considering a cone. So, you should have that imagination capacity that you have to build up in yourself. So, radian is used to measure a plane angle where we consider theta. We consider a circle. 2D image we will consider in case of radian. So, you saw how you measure the radian. Radian is given by d theta is equal to ratio of length of arc to the radius. So next, steradian is given as d omega is equal to dA by r square. It is an solid angle subtended at the center of the sphere of circle by the surface of sphere whose area, that is dA, is equal to radius of the sphere. So these are the concept about radian and steradian. So this is all about radian and steradian. These are the supplementary units. So next you have the derived quantities. We learnt about fundamental quantities. Along with fundamental quantities, along with the 7 base units, we have other 2 supplementary units. After that supplementary units, we have the derived quantities and units. So in this derived quantities, I have just mentioned few of the derived quantities which are derived from the fundamental quantities. Take the example of area. So how will you calculate area? Area is equal to what? How will you calculate? It is length into breadth, right? Length into breadth gives you area. Length is measured in terms of meter. We saw it in the 7 base units. So length symbol is, SI unit is meter and it is symbol is m. So breadth is also nothing but measurement of length, which is also given in terms of m. So what is area? It is meter square. Can you see the unit for area? It is meter square. So it is a derived quantities which we are obtaining from the fundamental quantities. Length is a fundamental quantities. From the symbol, from the unit of length, we are deriving area, that is a derived quantity which is nothing but m square, meter into m into m, meter square. So that is one example of area. Similarly, you can see volume, density, velocity, force, acceleration. All these are the physical quantities. But these physical quantities are derived from those 7 fundamental quantities. Similar to the example that I gave about the paints. So from those fundamental quantities, we are deriving these derived quantities. For example, take the example of volume. Take an example of volume. What is the formula for volume? It is area into height. What is area here? What is area here? Area is nothing but length into breadth. So it is length into breadth into height. Length is given in meters. Breadth and height is also measured in terms of meter. Length. So it's a fundamental length is and fundamental quantities. So length into breadth into height gives you volume. Length into breadth into height gives you volume. So length, breadth, height is nothing but m into m into m, that is m cube. So a derived quantity volume has a unit m cube. How did we get this m cube? We got this m cube from the fundamental quantities. So from the fundamental quantities, we are deriving these derived quantities. There are many derived quantities. There is large number of physical quantities. So under that large number of physical quantities, few are fundamental quantities, that is the 7 fundamental quantities. From that 7 fundamental quantities, we are deriving these derived quantities. There are many, I have mentioned few of the derived quantities. Did you understand how you derive these derived quantities? So one example I choose is area and volume, which is simple. You all people will be knowing about the formula for area. Length into breadth. Length is also in meter, breadth is also measured in meter. Meter into meter gives you meter square. From where did this SI unit meter square come? From the fundamental unit. Length is a fundamental unit. From that and fundamental unit, I derived a derived unit area, which is meter square. Similarly, you can work all these derived quantities, can check how these derived quantities work. You can see velocity is displacement by time. Velocity is what? Displacement by time gives you velocity. Velocity is displacement by time. Displacement is nothing but length again. It is the distance which is given in meter. Meter second. What is the SI unit? That is a symbol for time. SI unit for time is second. Second is given by yes. So meter per second, displacement by time. Displacement is nothing but distance, the length measurement, which we know it is in meter. Meter per second. You can also write it as meter per second. Meter per second can also be written as like this. Meter per second is also right. Meter per second. This representation is also right. So this is how we derived velocity using length and time. Those are fundamental quantities. From that length and time fundamental quantities, we derived the derived quantity velocity here. So next we have measurement of length. What are the equipments or the apparatus you use for measurement of length? You can see here, it is a meter scale. So you have a normal 15 centimeter ka scale. Similarly, this is the meter scale, which is large. You will use all these apparatus in your lab. You will learn what are this meter scale, what is this screw gauge, what is vernier calipers, and this is spirometer. What are all these apparatus, how it looks like, how exactly we do measurement using this apparatus. You will study that in your lab sessions. So measurement of length. How do you measure the length? So different objects, particles have different range of measurement. Up to certain range you can measure using meter scale. For a certain range of particle you can use screw gauge. So there are different types of instrument used accordingly to their range to be calculated. According to the range we use different apparatus. Here you can see few instruments. Meter scale. In meter scale the measurement of length from 10 to the power minus 3 meter to 10 to the power 2 meter. For this range, we can use meter scale. This is the meter scale. For screw gauge, next you have screw gauge. For screw gauge, measurement of length to an accuracy of 10 to the power minus 4 meter, we use screw gauge. You have vernier calipers and spirometer. For a measurement of length, for accuracy down to 10 to the power minus 5 meter, we use spirometer and vernier calipers. You can see here different apparatus work for different range of particles. For different particles, so according to the particle range, all particles for range of 10 to the power minus 5 meter, I cannot use meter scale. For the range of 10 to the minus 4 meter, I cannot use meter scale. Similarly, for different range of particle, we have different instruments that we can use for measurement of length. So for small measurement you use meter scale, vernier calipers, screw gauge, spirometer, etc. In case of large measurement, what will you do? I want to measure the distance of planet or star from Earth to the planet. So we use indirect method called parallax method. What is parallax? We use parallax method. You can see here, I want to measure the distance, which is large distance of planet or star from Earth. Will you hold the tape, measurement tape, and hold the length and measure what is the measured distance? You can't do that, right? Can you hold and go meter scale and measure what is its distance from planet to Earth? No, right? So you use the parallax method. In this parallax method is used to measure large distance, such as distance of planet or star from Earth. Here you can see the image. Distance of planet and Earth you measure using a parallax method. Suppose I have a whiteboard. Perform this practical with me. I have a whiteboard and I have a point here. And I'll keep my pen straight to the point. You can do it along with me. You will keep a point, hold the pen straight, close your left eye and look at the pen. You will find the point somewhere here. You will close your right eye and see the pen straight to the point through your left eye. So you see the point somewhere here. So that is the parallax. When you measure the pen holding straight to the point on the background, there will be difference in the measurement. That you can see in this image. Position A tries to measure this point. His observation point is at blue. He sees this in this angle. So when position B tries to measure this yellow color point or ball, it will be in the red point for him. So that is the difference of measurement. That is what we call it as parallax. Change in the position of object with respect to its background when the object is seen from two different positions. Same example of pen, that I am viewing the same point, that I can see the different position from when I see with my left eye and when I see with my right eye. I can see the when object is seen from two different positions, I am seeing that respective object, I can see there is a difference in the point. So that is what we call it as parallax. So here you can see, in this point on Earth you will consider 2 points A and B. From these 2 points you will measure a distance of star which is located at S, which is making an angle theta. And the distance from A to S, it is given as D, and distance from B to S, it is given as D. So, from Earth to planet or to a star, yes, I am measuring the distance. I am using parallax method. I am considering two persons or 2 points on the Earth, that is A and B. So distance between this A and B is very small, right? It's like a distance between your eyes, which is very small. That we call it as basis, which is represented by small b. The distance between 2 points of observation. So there are 2 observers on the earth, A and B. Distance between them, we call it as basis, that is B. Now, the distance of A to star, that is, I have written it as S. The distance from A to star, it is D. The distance from B to star, it is D. It is making an angle theta. Now, distance between 2 observers, that is small b, is small compared to the distance between earth to star. From the earth to star, the distance is very large compared to the distance between 2 points of observation. So, what will write? D is very much greater than 1. That is distance between planet and earth, or star and earth, it is large. So, distance between 2 points of observation, that is basis, is small than D. So, you can write it as B by D is much less than 1. So, here you can see distance from A to S, it is D, and also distance from B to S, it is D. So, you can write AB is equal to B. AB is equal to B. So, A to S the distance is D, and also B to S the distance is D. So, we will write AB is equal to B. Theta is equal to B by D. Theta is equal to B by D, or D is equal to B by theta. Once you get to know what is B and theta, what is the basis and what is the angle, you can easily calculate D. D is nothing but the distance from earth to star. You can easily get the distance D. Once you get to know what is D, you can calculate what is the diameter or angular size of that planet. Once you get the value of D, that you substitute B and theta, you get the value of D, that is distance of earth to planet, you can easily calculate diameter or angular size, that is nothing but alpha. Alpha is the angular size. You can get angular size once you know the distance of planet to earth. So, you can also calculate what is the angular size of planet using alpha. So, this is all about parallax method. So, next we have a numerical. Here, they listen carefully, they have asked calculate the angle of given value in radians. So, how will you calculate? Calculate the angle of given value in radians. Use 360 is equal to 2 pi, 1 degree is 60 minute and 1 minute is 60 second. So, this is degree, this is minute, double dash is nothing but second. Single dash is minute, double dash is nothing but second. Now, you can consider the solution. Use 360 degree is equal to 2 pi. So, then how will you calculate it for 1 degree? Then 1 degree, they have asked us to what is the angle of given value in radians for 1 degree, 1 minute and 1 second. So, then for 1 degree, how much it is? You will divide 2 by 360. So, that will give you pi by 180. So, it is pi by 180. So, once you know it is pi by 180, 1 degree is equal to pi by 180. So, pi by 180 is nothing but 0.0174 radian. So, when you convert it, it will get 1.74 into 10 to the power. I am shifting 2 points, 1 and 2. 1 and 2. So, it will be 10 to the power minus 2. So, it is 10 to the power minus 2 radian. So, 1.74 into 10 to the power minus 2. I am shifting 2 points, 10 to the power minus 2 radian. So, this is the value. So, for 1 degree, you know it is 60 minute. So, 1 degree 60 minute is equal to 1.74 into 10 to the power minus 2 radian. Then, how much it is for 1 minute? So, you cross multiply it. How much you will get? You should divide 1.74 into 10 to the power minus 2 divided by 60. It will give you 0.02908 radian. Always the theta should be converted in radian. You got to know how we convert degree into radian. Pi by 180 into radian, it is the conversion how you convert degree to radian. So, divide this, again shift the point, I will shift 2 points. So, I will get 2.9, I will approximate this into 1 into 10 to the power of minus 4 radian. So you have 10 to the power minus 4 into 10 to the power minus 2. You have minus 2 here. So 2.91 into, I'll shift one more point. So along with minus 2, why again 2 gets added up, 2.91 into 10 to the power minus 4 radian. So this is for 1 minute. Now you have 1 second. How much it is for 1 second? How will you calculate? For 1 second, that is C, you got to know. Now for 1 minute, you know you have 60 seconds. It is already given here. 1 minute is nothing but 60 seconds. That is equal to 2.91 into 10 to the power minus 4 radian. You got to know it is 10 to the power minus 4 radian. Then how much it is for 1 minute? How much it is for 1 minute? Cross multiply again. Divide 2.91 into 10 to the power minus 4 radian with 60. So how much it will give you? It will give you 0.048 into 10 to the power minus 4 radian. Again, shift the point, I'll get 4.8 into, shifting 2 points, I'll get 4.8 into, I have already 4 here, add 2 points, you get minus 6 radian. So this is for 1 second. So this is how you solve the numerical. Next you have the second numerical. So read the question carefully here. A man wishes to estimate the distance of nearby tower from him. He stands at a point A. So, here I have a tower. I have a tower. So, from the tower he stands at a point A. He stands at a point A. He in front of tower C. So, tower itself is C. In front of tower he stands at point A and spots a very distant object O in the line with AC. So, I'll draw a line AC. In the distant object, he will point a object. So, I'll join this line. So, he spot a very distant object O in the line of AC. He then walks perpendicular to AC up to B. So, this is parallel. So, the perpendicular is this one. He will walk perpendicular to AC up to B. Distance is 100 meter. He will walk 100 meter and looks at O. And from this position, he will look at O and C again. Look at O and C again. Since O is very distant, the direction BO is practically the same as AO. So, BO is same as AO. But he finds the line sight of C. He shifted from the original line of sight by an angle 40 degree. So, when he observes from this point C and from this B point C, he observes that there is a shift of angle of 40 degree. This is your theta. So, estimate the distance of tower from its original position A. From this position A, you have to find out what is the distance of this tower. So, this you have to find out. So, given things are, he has given what is the theta, it is 40 degree and AB, that is the distance is nothing but 100 meter. Now, all that you have to find is what is AC. Estimate the distance of tower from its original position A. From A you have to measure it. Now, what you will do is, I have an angle here. I will write it here. C, A and B. C I know it is 40 degree. AB I know it is 100 meter. I should find what is AC. So, this is your hypotenuse. So, he has given what is opposite to hypotenuse, that is AB he has given, adjacent I have to find. So, I will use opposite by adjacent is given by tan theta. So, I will use tan theta is equal to opposite by adjacent, that is opposite of hypotenuse, it is AB by adjacent I have to find out. So, it is AC is equal to AB, it is 100, tan theta is nothing but tan 40. Tan 40. So, tan 40 is nothing but 100 divided by 0.839. The value of tan 40 degree, it is 0.839. So, AC is nothing but 119.1 meter. Since I am measuring, what is the distance? I am representing it as in meter. Okay. Similar angle I have placed here. CAB, angle is 40. AB is the distance that he has given 100 meter, adjacent I have to find. When opposite is given, angle is given, adjacent is not given, it is given by tan theta. Opposite to hypotenuse, it is AB. Opposite by adjacent, it is AC. When you cross shift, AC is equal to 100 by tan theta, 100 by 0.839, that is 119.1 meter. So this is the distance of tower C from the original position A. So when you have a complex problem, never think problems are problem. Have patience, analyze and represent it in a schematic way. There was no diagram. I read it, I understood it in my way and I formed the diagram. Then write the given things, then substitute. So this is the second problem. Next you have different range of length. The size of different object vary over a wide range. In the universe, from a small object, that is nucleus 10 to the power minus 14 meter, that is a small size of the nucleus, to the observable universe, that is 10 to the power minus 26 meter, the length ranges. Length varies from small to large object. So these are the few objects and these are the length. You can see few objects I have mentioned. Size of proton, it is 10 to the power minus 15 meter. From the small to large range, you can see distance of a boundary of observable universe, it is 10 to the power 26. From the nucleus till the universe, you can see different ranges of length I have tabulated here. Next you have estimation of very small distance and size of molecule. So to measure a very small size, that is 10 to the power minus 8 meter to 10 to the power minus 10 meter, we adopt a special method. To measure a small distance, that is small size of this range, we use optical microscope, electron microscope and tunneling microscope. In optical microscope, optical means it is understood, we use light. So we use visible light in optical microscope, which has a range of wavelength 4000 angstrom to 7000 angstrom. Here 1 angstrom is equal to 10 to the power minus 10 meter. We will come to this in the next slide. 1 angstrom is equal to 10 to the power minus 10 meter. So the range of wavelength of optical microscope is 4000 to 7000 angstrom. So the molecule or particle with size or range below 4000 or above 7000, optical microscope cannot resolve the particle size below 4000 or above 7000 angstrom. When you come to electron microscope, from the name itself we understand, in electron microscope we use electrons. So electrons, here it has a resolution of 0.6 angstrom. It is 0.6 angstrom. It can resolve almost all atoms and molecules of this range. So it uses electrons to focus. Electrons, it is designed with a very well equipped electric and magnetic field which can focus the electrons or electron beam. So it can resolve particles, almost all atoms and molecules of this range. Next we have tunneling microscope, which are used these days. Tunneling microscope, it has a large and high resolution. So it can estimate the size of molecules. So tunneling microscope has high resolution. So we make use of this these days to estimate the size of small particles. When it is paper, pen or stick, you can measure the length easily. When it is invisible objects like electron, atom, molecule, how will you measure the length? Can you use meter stick or vernier calipers or similar object or similar equipments? No, right? In those cases, we make use of microscope. Scope can focus to the electron or atom or particle and measure what is its length. So these are the three microscopes we use to measure the small size or small distance of particles, that is atoms, molecules. Next you have some special length units are used to measure short and large length. So some special units are used. So for small range measurement, we use Fermi. 1 Fermi, that is 1 F is equal to 10 to the power minus 15 meter. 1 angstrom is 10 to the power minus 10 meter. So 1 Fermi is what? 10 to the power minus 15. 1 angstrom, that is 1 angstrom is 10 to the power minus 10 meter. This is for small measurement. For large measurement, to measure planets, stars or for large distance measurement, we use the term 1 astronomical unit, 1.496 into 10 to the power 11 meter and 1 light year. So it is the time that light takes to travel in 1 year with velocity 3.8 into 10 to the power 8, which is constant. So 1 parallactic second. So 3.08 into 10 to the power 16 meter, that is equal to 3.26 light year. So 1 parallactic second we use to measure the stars, galaxies outside a solar system. So 1 astronomical unit, that is the distance between the sun and earth, 1 light year, the time taken by light to travel in 1 year with velocity 3 into 10 to the power 8, which is constant. 1 parasec is used to measure the size of galaxies and stars which is outside our solar system, for large measurement and for small measurement. Next you have measurement of mass. In this measurement of mass you can see, even mass, different particles has different range, different object has different range. So mass is the fundamental unit which has a SI unit kg. Kg is the SI unit for mass, and mass is the internal property of matter. It is a property of matter. So since it's an internal property, it does not depend on the external properties like temperature, pressure or location in space. They do not depend on the external properties. Mass is the property of matter which does not depend on the external properties. So mass is defined as the amount of matter present in a body. SI unit of mass is kilogram, represented as kg. So mass of object we can come across in the universe vary from wide range, from 10 to the power minus 30 kg, that is for electrons, to about 10 to the power 55 kg of known universe. So similar to length, mass also varies in a wide range, from the small object like electron to the observable universe. They have different ranges of mass. So when you want to buy a orange, 5 kg of orange, you'll go to market, you'll ask for 5 kg orange, you can buy it off. So these are all the normal weight balance that is used in the markets or in the grocery store. So what will you do when you want to measure atoms or molecules? If you want to measure atoms or molecules, what will you do in that case? Will you go to market and ask, I want 1 kg of atom, 1 kg of molecule? You cannot use kg in those terms. In those cases, when you measure atoms or molecules, a kg is inconvenient. So you use atomic mass unit there, which is represented as U. So 1 U is equal to 1 by 12 mass of atom of carbon-12 isotope. It includes the mass of electron as well. So 1 U is nothing but 1 U is 1 by 12 mass of atom of carbon-12 isotope. 1 U has a value of 1.66 into 10 to the power minus 27 kg. So to measure atoms and molecules, we use a standard known as atomic mass unit, represented by U. You know what is the value of 1 U. So there are different methods for mass measurement. So to measure atoms or molecules, you cannot use the normal weight balance that you use in the markets. So these are the normal weight balance used to measure small things like apple, orange or any grocery items. You use normal weighing balance. After weight balance, you can use gravitational method. In gravitational method, you will measure what is the large masses of star, planets, all these are which are based on Newton's law of gravitation. We measure it with the help of gravitational method. Third is mass spectrograph. In mass spectrograph, you measure the atoms and subatomic particles, and also you can measure the ion ratio in case of mass spectrograph. So mass spectrograph, you use to measure the atoms and subatomic particles. Gravitational method, you use the measure the large masses of planets and stars. Weight balance is a simple, you use it to measure the any grocery items in grocery stores. You can see this normal weight balance, which is used for measurement of small objects or small things. So next you have different ranges of mass. As I said, range of mass varies in a wide range, from electron till the observable universe, from electron 10 to the power minus 30 kg to observable universe 10 to the power 55 kg. So the mass really varies in a wide range, from small to large. Next we have measurement of time. In measurement of time, in earlier days you used to know how people used to measure time. Time is measured based on the length of shadow cast by the sun. It is measured by the length of shadow of object cast by sun. Or in days to see weather and days to tell what is the time, what is the current time. In these days you have wristwatch, you have wall clock, and you have different pendulum clocks to measure the time. So now in this measurement of time, you can see time is a measured using a clock. SI unit for time is second. To measure a time interval, these days we use an atomic clock, that is nothing but the cesium clock. So now we use cesium clock, and also known as atomic clock, in which time is based on the periodic vibration of cesium atom. What do you mean by cesium clock? Say we have ground state. This is our ground state. In this ground state, we have two hyperfine levels. This is the energy difference, nothing but the energy difference in the ground states. In ground state, we have two hyperfine levels. That hyperfine levels is nothing but the energy difference. When cesium-133, you can see here, cesium-133 atom starts to undergoes the transition. Cesium-133 atom undergoes this transition. What will happen? During this transition, a radiation is released out. This radiation consists of vibrations. This consists of vibrations. So, 9192631770 of vibrations is equal to 1 second. So, radiations will emit vibrations. Emitted radiations will have vibrations. So, these many vibrations is equal to 1 second. So, 1 second. In cesium clock, a second is equal to these many vibrations of radiation from the transition between two hyperfine levels of cesium-133 atom. So, cesium clock is nothing but the atomic clock used to measure the time interval, and in cesium clock you got to know what is 1 second. 1 second is equal to these many vibrations. So the measurement of time ranges from 10 to the power minus 24 second for lifetime of an unstable elementary particle to 10 to the power 17 second for the age of universe. So to measure the time range from 10 to the power minus 24 second to 10 to the power 17 second, you can see from the small particle up to the age of universe, you can see how the time ranges. This time range of small particle to the universe, I have tabulated in the next slide. So this is how the cesium atomic clock looks like. So cesium clock is an atomic clock used to measure the time interval. In cesium-133, you got to know how it undergoes transition. It releases a radiation. In radiation, there will be vibration. In cesium atomic clock, 1 second is equal to these many radiation. This is how it undergoes transition in the ground states between two hyperfine levels, that is the energy difference. So these are the range of time. You can see events from the small particle, lifespan of unstable particle, that is time is 10 to the power minus 24 second, and period of X-rays 10 to the power minus 19 second. So from the small till the observable universe, age of universe, how the time varies. So in this session, students, we have learned what is unit measurement physical quantity. When you have a physical quantity, how do you measure that physical quantity? How you exactly give the unit? For example, I had taken the measurement of length of this pen. 10 centimeter. 10 is a numerical value, that is a physical quantity. Length is a physical quantity. This physical quantity is referred using a standard unit meter. So 10 meter. So that is how unit and physical quantities that we saw in this today's session. Measurement, you learned how we measure length, rod, stick, etc. Next we saw physical quantities had two branch, fundamental quantities, derived quantities. There are 7 fundamental quantities, out of which we derive the derived quantities. We saw the example of area, volume, how those derived quantities are derived from these 7 base fundamental quantities. And we know international system of units, that earlier people used to follow CGS, FPS, MKS system. Then after 1971 we follow the standard system of unit, that is SI unit, which use decimal system. That's why conversion or using SI unit is simpler. After that, how do we measure the length? Length is measured for small object. We use vernier calipers, screw gauge, speedometer. All these are the equipment used to measure the small length range. In case of to measure the large distance, like I want to measure the distance from a planet S to Earth. So I can't use meter tape or some scale to measure the distance. I'll use parallax method. You understand? Parallax method, theta is equal to B by D, or D is equal to B by theta. Once we get to know what is the value of distance D, capital D, we can get angular size or angular diameter of the planet. Next, we had come across different types of microscope that we use to measure the length. Optical microscope, electron microscope, and also What is another type of microscope? Tunneling microscope. To measure a small particle, if you have pen or if you have a paper, you can use different meter scale or screw gauge to measure it. When in case of elementary particles or a small molecule atom, you can't use meter scale or vernier calipers. What you'll do? You will use microscope. Microscope will focus the particle and you can find what is the length or distance of the particle or size of that. So next we saw measurement of mass. We saw two numericals, how we analyze numericals, how we convert degree to radian, and how we sketch the numericals by reading the question, write the given things, write the answer. Next we saw measurement of mass. In measurement of mass, we saw what is mass. So what are the quantities, that external quantities that it does not depend on. Next, to measure the mass, we can use different methods like weight balance. To measure grocery items or to measure the orange, apple, we use weight balance. In order to measure the mass of planet or earth, we use gravitational method, which is based on Newton's law of gravitation. And next we use mass spectrograph, where we can measure the mass of atoms or subatomic particles and ion ratios in mass spectrograph. And also to measure atoms or molecules, we cannot use kg. Kg is inconvenient. To use electron, to measure mass of electron or atoms, we use standard atomic mass unit, which is represented by U. And 1 U is equal to, what is the value? You had seen that in the previous slide. And also student, we studied different ranges of mass from the small electron till the observable universe. What is the range of mass? After that, we studied the measurement of time. How earlier people used to measure time, and now we have different watches or equipments to measure time. And we have cesium clock, which is also known as atomic clock, used to measure the time. So in cesium clock, you know 1 second is equal to how many vibrations. So that many vibrations is equal to 1 second in cesium clock. And it is cesium 133 atoms undergo transition and give out the radiation, which include vibration. So that vibration value, so much value will give you 1 second. So we use cesium clock, which is a atomic clock. So we still have in India, we have cesium atomic clock maintained at National Physics Laboratory at New Delhi. That's all about today's session, students. Next, I'll be coming up with more interesting sessions on units and measurement. I'll see you all in the next session. Until then, take care. Have a good day. Thank you.